Good morning, guys. The warm-up's on the board. As soon as you're settled, draw the Lewis dot structure of carbon dioxide. 2 minutes. All right, we're about halfway through, so there's your little cheat list. Even if you have the structure drawn already, you're fast, and that's awesome, but double check you didn't miss a step. 1 more minute. All right, so you're going to check off your structure as I'm going and doing it here. Determine the central atom. Well, first we need to know who we're dealing with. Carbon dioxide. 1 carbon, and di means 2, so 2 oxygens. So that's the structure we're going to be building. Draw the Lewis dot structure. Carbon, 1, 2, 3, 4. Valence electrons because he's in group 14. Oxygen, 1, 2, 3, 4, 5, 6 valence electrons because he's in group 16. How many gaps or how many bonding sites does he have? Okay. Oxygen has 2, so he can now have 2 bonds. Carbon has 1, 2, and if I slide this electron over, give him some more space, he actually has 4 bonding sites. 4 beats 2. You want somebody who has more options in the center. And you put each of the oxygens around that central atom. Step 1. Step 2, count the electrons. 4 carbons plus 6 on oxygen, but now we know there's 2 oxygens. 16 total electrons. Not super critical for what we're doing today or the last couple of days, but when we do ions, it's important to know what your total electron count is. Give everybody single bonds. So that means from the center to each outside. Single bond. And then let's see if they're happy. Carbon has 4 electrons. We're going to think of these as dumbbells, remember. So carbon already has 2 electrons here, and he needs 2 more to make his 4, to make his valence. So, and then oxygen has 1 that he's sharing in the bond, and then 2, 3, 4, 5, 6. Oxygen, 1, 2, 3, 4, 5, 6. Post in the chat if he is happy. 15 seconds before you hit enter. And hit enter. Yep, you guys are right. He's not happy. Good checking in. All right, so we need to level up. So when we level up here, we're going to add another bond. Okay, and so that means we had to take an electron from each side. Now, since this guy is totally symmetric, I'm going to assume that I can do the same thing on the other side and take the other electron off carbon and 1 off of oxygen. Okay, now when we check to see if he's happy, 2, 4, 6, 8 on the left oxygen. Carbon, 2, 4, 6, 8 electrons. The other oxygen, 2, 4, 6, 8. They all are sharing for a total of 8 electrons. That's the octet rule. Full crown, remember. So they are all happy now. Let's make sure we didn't make any other mistakes. And so let's check valence just to make sure. 1, 2, 3, 4, 5, 6. Oxygen has 6. 1, 2, 3, 4. Carbon has 4. And lastly, 1, 2, 3, 4, 5, 6. So we've met our octet and valence rules. So this means this is really the stable form of carbon dioxide we can be pretty confident about. Oh, yeah, the dumbbells are just for right now, just for visualizing. If you can draw it without the dumbbells, that's fine. I'm going to rewrite mine now so it's prettier. Before I rewrite it, I do want you to look at this picture that's up here and tell me what is wrong with it. Okay, 20 seconds might take you a little bit longer. What is wrong with the Lewis dot structure that is shown right here? What is the problem? Okay, 20 seconds. And hit enter. Absolutely right. When they did theirs, they did not draw all the electrons around it. Okay, so they didn't check to see if it has an octet. So looking at it this way, sorry about that. Looking at it this way, it doesn't have an octet. Okay, we know in actuality that he does. Okay. So you are okay if you have this drawing, but in year 1, do not have that drawing. Okay. Sometimes we just don't write it, and you're going to see that when we do the lab later. It's not going to care about other electrons. You still want to have it on your Lewis dot structure so that you can show those octets. Okay. We're doing today with carbon dioxide is we're doing more like this ball and stick on the left side. Instead of building them, if you were in person, we get to build them on the computer. Okay. And just so you know, Vesper 20, just a review. 2 atoms besides the center, and no lone pairs, no electrons that are unbonded on the carbon. That gives him a 20, and from the chart, he's linear and 180 degrees. So just a quick little review on that. Now we're going to go to molview.org. I know you guys are going to want to play around on here, but pay attention just to the first part. If you see on this other side, okay, this is called the model space on the right, and you can rotate your molecule around. If you look at it when it's flat here, notice the red one has a double bond. So if you look over here on the paper space, you can find that that's the oxygen that's in red, double bonding with a carbon. And that means that gray is a carbon. And the blue, okay, that only has 3 bonds if you look. So that's not another carbon. Okay, that would be the nitrogen there. Okay? And those white ones are the hydrogens. So you can look at your Lewis dot structure on the left, okay, and then you can compare it to your model on the right side. And again, remember, Lewis dot structure have your electrons on it, but when we're doing it here in more like the organic format, you're not going to see those extra electrons, and that's okay here. Right. So we're not going to draw anything that fancy. So we're going to hit that little trash can, and that's going to clear off the paper space. The trash can in the upper left-hand corner clears off your paper space. Okay. And then we're going to draw carbon dioxide. That's where all our elements are. In fact, if you wanted to use any other ones, you can pull up a periodic table there. We just need carbon, so you select carbon. Once it's highlighted, then go ahead and put a little C on your paper. And then the next thing that you'll do is you'll be drawing your oxygens. 2 oxygens. You don't have to place them perfectly. Okay, and if you're using a touch screen, you can just pinch and grab. Okay. Okay. And then we have to add our bonds. Singles the top, doubles the next one, looks like the equals, or triple. Hold down on one oxygen, drag over to your carbon. Oh, I was on triple. Hit the undo button. Double bond. Click, hold, drag. Now I have 1 double bond. Click, drag. Okay, now I have the second double bond. Okay, now this is carbon dioxide. So you can take a picture just like this. Oh, no, you can't. Why not? Because that is not it on the model space. Okay. So some people like to clean it up a little bit. If you didn't have that CH button clicked, it's going to actually make that carbon disappear, because in chemistry sometimes we don't like seeing that carbon in the center. And it's just mainly because we're lazy, so we assume that a bend is carbon. But use your CH button if you need to see that carbon in the center. And you can also use the broomstick. Just be aware that sometimes when you do it, it doesn't actually clean it up, and then you have to undo it again. But in this case, it did a good job of doing carbon dioxide. So once the model on your paper, it looks good, and page over 2D to 3D. Now you have your carbon dioxide over there. You'll screenshot that. So you have your Lewis dot structure and the paper space and model space, and that's what you get credit for. Any questions on how to do molview? Okay, I don't see any questions coming up. I'm going to put it on host only for the chat. To your exit ticket out of here is to tell me the formula of carbon monoxide, and I'll stay on if anybody has any questions. Yep, you're good. J, you're good. C, you're good. Yep. D, yep, you are good. All right, have a great day.